Need a last minute gift for dad? The 23andMe DNA test is on sale and arrives in time. DNA test leads to shock revelation for two families who used IVF. Their sons had different fathers due to a sperm mix-up. That's not great. Australia skipping genetic screening tests out of fear it will affect life insurance coverage. Life insurance coverage. The potential for this to ruin people's lives is enormous. The views expressed in this podcast are my own thoughts and opinions. They do not reflect the values of my employers. Hello, welcome back to the Crossover Connections with Jack Wayne podcast. My name is Jack and I'm an Australian scientist and professor. This podcast aims to explore the recent headlines in science, technology, and productivity to see how everything is truly connected. And in this episode, we are focusing on the huge quagmire that is online genetic testing, or just genetic testing full stop. This is quite a bit of a minefield, and for a number of years now, it's seen to be the cool, hip, and happening way of finding out more about yourself in terms of your DNA, but making it so accessible and essentially privatizing it, where companies are offering these genetic testing kits. Don't want to just single out 23andMe. This is one of these many services trying to unpack the intricacies of DNA and making it seem very easy and palatable, understandable, that has hidden a lot of the much more insidious aspects of genetic screening and how that impacts our quality of life. To make sense of this, let's look at the first headline here. The use of something like 23andMe, which uncovered a rather salacious detail in this family, and this idea of having sons from different fathers is not uncommon. Many families have this makeup, but in this case, it was due to a mix-up during IVF. To understand these family dynamics a little bit more, I believe this couple had one son biologically, perhaps had trouble conceiving later in life, and then it decided to use IVF to try and conceive another son. And they went through the clinic, and the father would have donated his sperm as part of the IVF process, but it turns out that another man's sperm was used to fertilize the egg in IVF. And so the two sons actually had two different biological fathers, one being the one that lives with them, and another one being some donor in the IVF clinic that they'd never met before and didn't know existed. And 23andMe really was the one to highlight this. One of the sons had a father unknown. That's a good indication that this technology has been democratized, that people can use it for bonding exercise, but reveals actually very deep personal information, because that's what at the heart of it, all of this is. Genetic information is truly deeply personal, and it's not just personal about your own state of being in your own life. It extends towards your family, it extends to your generations. You can uncover something about yourself and your own DNA that would then make your family members have to make very difficult medical decisions. Let's say you are at risk of a certain genetic disease, and that gene is very likely to be carried by all the other members of your family, whether they be your kids or your mum or your dad or your grandparents, and they didn't really want to go through and do that screening for that rare genetic disease. You finding this out really forces them to have to make that decision as well. And if it's for the sake of preventing disease, that is a very noble cause. If it's for the sake of affecting their quality of life, because they're now burdened with that knowledge that they do have risk factors for developing diseases, that is a very heavy burden. So I'm very conflicted on this. I'm a huge fan of innovation. Unless it's coupled with some very common sense regulatory frameworks that sit on top of it, the potential for this to ruin people's lives is enormous. Thankfully, in this case, I don't believe their lives are ruined. I think this was an opportunity to connect with the biological father of their son, but you never know how a genetic test is going to impact you in ways that you can't quite predict. The next article is a throwback to when this company and this kind of technology where genetic testing can be ordered online and everyone can have access to it for a couple $100. This was at the inception of this trend. There were already warning telltale signs from thinkers in this field, from ethicists, from journalists, saying that this kind of approach could have huge unintended consequences. This article is from the Scientific American, talking about the terrifying nature of 23andMe is not because of the accuracy of the testing, but it is about the kind of data that these companies are collecting. It is to hoard your personal data. So again, this is back in 2013, so this is a decade ago. And let's look back at the predictions this article made 10 years ago. Fast forward to today to see how many of those predictions are actually correct. This article talks about having a gene for hubris, Icarus-like gene for flying so close to the sun without fearing your wax wings being melted. The 23andMe crew were at the time in a dance with the US FDA as to how much regulatory oversight that they should be under scrutiny for, billed as a health and medical service, where they're being billed as a kind of fun activity to get into. And they were really trying to have a very, very light touch in terms of the regulations. They did not want to be put under more scrutiny or more rules than they have to be. They're a company, they're trying to make money, so less regulation would give them more flexibility to boost their bottom line. That's just economics 101. They were really giving out genetic testing for a long time, and people were spinning in vials and sending it into this service. And again, I'll reiterate, 23andMe is the most famous version of this type of service. They're not the only type of service, so we're not trying to single them out, but this kind of analysis would apply to any private company that's offering genetic testing. And you can really identify a certain range of different types of features in your genes, inability to smell asparagus. Some kind of genetic basis can be used to explain that away. And it's kind of fun. Oh, you know what? I can't smell asparagus in my pee because I've got this rare genetic variant. Kind of a cool thing to share at cocktail parties if you're really that way with your friends and family. At first, it seemed like it's a fun way to learn a little genetics using yourself as a test subject. But what happened was the FDA had a bit of a problem with correlating this information to kind of health advice. Your service then needs to be verified, needs to be vetted to check for accuracy, and that's the last thing 23andMe wanted at that time, probably the last thing it still wants to this day. There is much more interesting things in your genome than novelty items. For example, the risk of breast cancer, the onset of metabolic diseases, and sensitivity to medication. Before you knew it, this kind of testing really veered much more closely to health and well-being and almost being predictive, if not diagnostic, of these life-altering diseases. So any kit that was intended to cure, mitigate, treat, prevent, or diagnose a disease is, according to federal law in the USA, a medical device. So something that the FDA has to regulate, and really they have to negotiate with the agency to try and find out how much of these rules they would be under. There was a little back and forth at the time about FDA regulation and how much scrutiny this kind of company would be under. Actually, that was missing the point, because the point is not about the accuracy of these predictions. And this journalist was very, very almost conspiracy theory minded about this, in that the access to personal genomic biological data was the real gold mine here. The Personal Genome Service is meant to be a front end for a massive information gathering operation against an unwitting public. Again, this guy's a writer, so very, very dramatic in their setup of the stage. Does this sound paranoid? They made the analogy to Google, and they did say, indeed, one of the founders of 23andMe was married to the founder of Google during the time that this article was written. And Google also billed itself as a servant to the masses, trying to build the best tool to help you find information, but over time turned the information we were searching for into an enormous data set on what people are interested in, that it could then service targeted ads into our feeds. So that really is the ultimate aim that to this day, really, Google still makes billions and billions of dollars from all the time. So the search engine for Google is essentially the data that we are submitting, akin to the saliva sample that we're submitting to 23andMe. The money that they're getting from that isn't the value we're getting in the moment from the search result or from what we find out about our own DNA. It's the information they can keep and extract and potentially sell to others. And what 23andMe wants to do with the data is indeed to do with medical research, potentially giving all of this type of DNA sequence into a service that understands the variability in genomes. And I think that is very interesting work, because the Human Genome Project, which was the biggest, most ambitious research project in the history of biology, trying to sequence every single base pair, every single letter in a complete human genome. Nowadays, because of that project, sequencing of DNA is a lot quicker, a lot cheaper, so it's not really as much of a concern as it once was. The samples they had access to were so few and far between, it did not reflect the variability across all the genomes across that many people, because, well, it's just one genome for a start, and even then it's a reference genome made up of lots of different pieces. The fact that 23andMe has this enormous database of complete human genomes, that would allow us to make way more accurate predictions down the line. Maybe not in the moment about your asparagus and wheat, but maybe in the future it would have that predictive ability given the statistical power so many genomes would give you. 23andMe was collecting all of these biological samples. They made the promise to safeguard your privacy and to do so responsibly and to advance medical research, all these very noble claims. We've heard that one before. Back when Google's first launched, the founders insisted the company would never sell you out to advertisers. It admitted it would share aggregate information, but the company's privacy policy promised that information about you will not be disclosed to any third party without first receiving your permission. That has completely reversed. Google is just selling our data willy-nilly and making a sweet profit off it. And the prediction here, 2013, was that 23andMe, like all of these services, would be under some kind of financial pressure to make revenue, and they would eventually turn to selling our data. Let's fast forward 10 years now. This is featured in Bloomberg, the next article. All those 23andMe spit tests were part of a bigger plan, and the CEO wants to make drugs using insights from millions of customer DNA samples and doesn't think that should bother anyone. The article from Scientific American in 2013 predicted this almost verbatim. The whole premise of this article, they were able to use the enormous number of spit samples and feed this information, feed the genomes to their partnering big pharma companies and give them the basis, give them the ammunition to really ramp up the development of all of their pipeline drugs. We talked about drug discovery on the podcast in season 1, but essentially this is a really expensive endeavor, making new drugs. And the biggest problem is that most of these drugs can't account for the true variability across the human population. We are so variable in the way that we respond to medications and respond to different therapies that any new drug has an enormous risk profile in terms of both financially, like it may not work, so we'll lose a lot of money, as well as biologically. It may just harm a significant portion of the population, and therefore it should never be administered. It should never make its way to market. Like all the articles we talk about in the podcast, this one is linked in the show notes below. And if you read through it, it's essentially a bit of a showcase of what 23andMe have pivoted towards in becoming essentially their own version of a big pharma company. At least those ties are so close. They've got these enormous facilities. They've partnered with GSK. They also have developed new drugs, cancer drugs that block certain proteins, and they've developed it in-house after discovering a series of biological pathways built upon all of those spit samples people were submitting to the service. This article was featured in Bloomberg, so it focuses on things like stock prices and the amount of revenue they raise and all that stuff. And I think it paints a relatively rosy picture of 23andMe in terms of the promise that it can deliver, the drugs that it's helping to design in collaboration with Big Pharma, and the impact that it's going to have on people's everyday lives. Trying to spin that dystopian view in that 2013 Scientific American article into something a little bit more positive. The reason that it's not so rosy, the information that they've been collecting from all the people submitting samples can be used for other reasons as well. And this brings me to the next article in Vox. Genetic testing is an inexact science with real consequences. And this article highlights quite an insidious application of DNA testing that it can be used by law enforcement. 23andMe is a private company, but depending on the application, law enforcement agencies could force 23andMe to disclose genetic information citing exigent circumstances, if it's for national security reasons or if they're trying to solve a crime. If they suspect someone of having committed a murder and their DNA is in this database and they can check that they've accessed the DNA, then they could go in there and obtain the DNA sample without having that suspect's consent. In a recent high-profile case, authorities were able to track down the Golden State serial killer after 4 decades using DNA from his third and fourth cousins who had voluntarily updated their DNA results to a public site where people go and find long-lost relatives. And what's more, this is a resource that police apparently routinely rely upon to help investigate their crimes. In the case of cold cases, these could be people that have already passed away. So they could help clear cold cases using this kind of resource. This really shows that giving this really personal, sensitive information over to any agency, any doctor, anyone outside of you, that is something that shouldn't be a decision lightly made. There is a real cost of both deciding to do a genetic test and also opting out of one when you very well know the risks involved. So let's say you have a family history of a genetic disease and you want to know how at risk you personally may be. If you decide to do a genetic test and have it on a registry, will that affect how you're perceived by those around you, your family, your employer, at worst case scenario, or all of the different federal law enforcement agencies that might track your DNA down? That's a really big call. Genetic testing is great to be democratized, to be very accessible, but genetic information can be tremendously powerful and damaging. Interpreting that information should be something that's very carefully regulated. There are many Australians skipping routine genetic screening tests for diseases like breast cancer because they believe once they know their risk of certain cancers, of contracting certain cancers, their life insurance coverage will be impacted. This story is Australian specific, but the philosophy kind of applies globally. The recent report in Australia shows that Australians are choosing not to have tests or partake in medical research because they fear the results might affect their life insurance premiums or prevent them from accessing certain health coverage. And of course, that's very dangerous. And the example they use in the article is a gene called BRCA1, BRCA1, which has a very, very strong correlation, if not causation, with different forms of breast and ovarian cancers. So for women, it's very important to go through and do this BRCA1 screening. If you do it in time, it could very well save your life. But this knowledge is very specific to one type of genetic disease. So in this case, it makes sense to do this genetic screening, not to do it lightly, but it should be part of something that you talk with your GP every year to navigate how at risk you are for certain diseases. But people are afraid that once they do the test, the health insurance companies will misuse that information and then double the premiums they have to pay for health insurance or life insurance. And really in Australia, we do not have that much protection against this kind of insurance company shenanigans. And the Federal Parliament Committee in Australia in 2018 recommended the use of predictive genetic tests results in life insurance underwriting to say that this should be banned. You should not be able to use genetic testing to influence life insurance policies or premiums. But really, there is not very strong guideline at all. In Australia, genetic tests can't be collected by the insurer for policies up to 500,000 Australian dollars. And if this is a life insurance policy, that's nothing. Like $500,000 really won't cover most people's ability to pay a mortgage for more than 5 to 10 years at most. So if this was supposed to cover your whole life, this really won't apply. Most people's life insurance policies will be higher than $500,000. So what that means is most people's life insurance policies will be influenced by genetic tests if that is available. And let's say you go and do a genetic test, you find out that you are at risk of a disease, and then you choose not to disclose that to your insurance provider. And for some reason, you decide to make a claim later on, or your family makes a claim. They will go through and dig through your medical records and find out that you knew about this risk and void that whole claim. That's really, really dangerous precedents that these types of regulations are setting out, and understandably so. People feel like they should not be dipping their toe into the pool of doing their own genetic tests to screen against these diseases because it will affect all of their perceptions from healthcare providers as well as from their insurers. There is discrimination against people who are trying to survive. If they have bowel, liver, and breast cancer, like this particular woman in the article has, and they want to encourage their own family members to go screen for these cancers because there's a family history of it, then this type of survival mechanism, this preemptive understanding of your own biology to protect yourself, is being discriminated against financially. The UK and Canada apparently are better protected in terms of consumer protections for insurance agencies having access to your genetic testing than other countries are. The idea that we are more vulnerable really highlights that this problem is not something that we can fix at a personal level, because personally, what you should be doing is getting all the facts about your own personal health and taking responsibility for it. I would say doing a whole of body, whole of genome screening test isn't that effective, but if there are known cases of this disease in your family that has a genetic component, doing the screening test will allow you to protect yourself over the long term. And if that means a slightly higher premium, that might be a price you have to pay. So again, this is not something that the individual can fix. It should be really on the regulatory front. The government and the governmental agencies and the experts should really be lobbying for tougher regulations that ban the connection between insurance company premiums and predictive genetic testing. But this is a very specific set of tests that have a very strong diagnostic function in the case of something like breast cancer. Which brings me to the last article in this series of headlines that we'll talk about today, which highlights the accuracy and reliability of these genetic tests that you can buy online. online DNA tests extremely unreliable at detecting rare disease-causing genetic variations. The technology used in genetic testing is something called SNP chips, and their primary job is to scan the whole genome very quickly, because that is as much as that $200 kit can afford to do across your whole genome. So you're looking for superficial differences, because if you really wanted to scan every single base pair in the genome, you could do it, but it would cost way more than a couple of $100 in these SNP chip analysis. I would say that if it was done by the right service and it was done by a proper sequencing platform where it's got amazing coverage, then you could bring that cost down as well. But really, at the level that 23andMe is pitching it at, it is very unreliable for detecting rare genetic variants. So for instance, they give again the example of the BRCA1, the breast cancer gene. The SNP chips, which is the technology used by companies like 23andMe, are not reliable at all in detecting those variants. So if you suspect yourself of having some kind of genetic disease that runs in your family, do not rely on 23andMe, get the proper genetic test, because the difference in the technology is that proper diagnostic tests will go through and sequence the entire gene in question, thousands of base pairs. Will go and sequence every single base pair, if not your whole genome, but really it needs to be targeted at that one area in the gene that will tell you every single base pair there and highlight it and compare it to all of the other known variants, all of the other different versions of that gene that may cause a disease. The 23andMe SNP chip type test it's just sampling a very small portion of the genome, looking for the sections that might have very obvious tweaks, but it is not looking or doing a deep dive on any one gene. That's the difference between the commercial DNA kits versus doing a very detailed diagnostic test that has been developed by many scientists over time. SNPs and SNP chips are not the right tool for the job. They're good for finding genome-wide associations, but they're not good for seeing if your individual version of this gene is prone to disease. That is way more detailed work that requires an in-depth test. Australians are taking genetic information provided to them through direct-to-consumer tests and putting them into third-party websites to try to determine if they have a rare disease causing genetic variation. And the test and technology is just not robust enough for anything to be interpreted correctly. So if you're in fear of this, it's actually going to make you have way more anxiety around your health than the intended purpose of trying to protect yourself and arm yourself with all the information. So it is much better to go directly to genetic testing services through a family cancer clinic in Australia if you meet the certain family history and you have eligibility to qualify to get this testing. And on the note of the power of information, that brings us to this week. Whose job is it anyway? Our recurring part of the podcast talking about employability and jobs in the future of science and tech. Someone, somewhere at some point in time, put the job genetic counselor into every single high school career counselor's notebook at some career counselor fair and told them, if your students study science, they can get a job as a genetic counselor. And I've had so many students come through high school into university thinking that all of them will walk into a genetic counselor job because genetic testing is going to take over the world and everyone's going to need to make sense of the information and talk to someone about what their genetics mean. That is a very specific job that not everyone is cut out for, because you have to know both the science behind why the genetic test is interpreted the way it is, which takes a lot of training. But you couple that also with the counselor side, having the people skills, having the communication skills to empathize with someone going through the familial trauma of dealing with generations of inherited disease and the impact it's going to have on their children and their children's children. You need a very specific individual to straddle both of those skill sets to do this job well. Nevertheless, it's a very important work, but I just want to highlight that it's maybe not a routine part of the science and tech economy just yet. Let's do a quick search for genetic counselor jobs in Australia, and you can see that across our country using this web portal, there are 27 results for the search term genetic counselor. And if you actually look through the results here, there's a diagnostic audiologist, a customer care operator at a children's research institute. There is a CEO. Well, that's good. A CEO. That would be a nice job to have. A specialist in molecular pathology, a head of legal, a fertility nurse. So really, all of these are adjacent to the job of genetic counselor. It's not actually a genetic counselor job. So this is just to reinforce the idea that this job is a very important role, but it is not yet a standard part of our science and tech economy. Does it mean that you shouldn't be aiming to study science and tech and genetics in particular because this was the only job you thought you should be doing? No, of course. It's really important to study science because science will teach you the transferable skills that are applicable across multiple sectors, multiple industries. And I'll give you a case in point. If I optimize my search term on this job website, and instead of searching for a very specific job, genetic counselor, I search for just the term genetics more broadly. So we had 27 jobs searching for genetic counselor, but we just searched for genetics. We've expanded our pool into over 1,000 jobs, 1,122 jobs. So there are sales engineers, there are study directors for immunoassays at biolabs, there are scientist jobs, there are genetic product specialist jobs, there are certain different types of scientists, future scientists, administrative officers that work for cancer genetics companies, cancer genetics places and organizations. If you're doing a degree that trains for one particular job, that job better be such a standard part of the economy that you cannot escape this role in any way, shape, or form. Doctors, lawyers, nurses, all these are essential workers that have to be around. That's how those professions can still manage to recruit and train a lot of people every year. Genetic counselor is one very specific job, but the skills you need to become a genetic counselor, understanding genetics, understanding laboratory skills, the analytical skills, as well as the communication skills, they can be applied towards 1,000 times more jobs than just that one single role. So as you're approaching your study and career options, don't go into thinking that I can only do this one job or I'm only training for this one very specific role, because if the economy changes, if the world pivots and there's no longer that much demand for that one very specific job, unless, of course, again, your job that you really want is the role that will never ever change. I'm not really sure I know of any job that will never ever change. Having an understanding of learning transferable skills applicable across multiple areas will always benefit you more in terms of your value to any employer than having tunnel vision trying to train for one very specific job, or at the very least that one very specific job you're heading towards hopefully will make you learn lots of different skills that are broadly applicable and that is much more useful in any employability landscape. Change is the only constant and you will be ready for the next challenge ahead. So I would like to reinitiate our recurring segment on the podcast called The Connect, where we look at previous issues and previous headlines we talked about. But we're in our second season, so we've received quite a lot more engagement from the audience. So thank you for those of you who have commented and gave me some feedback. Comments I'm looking at are from the video I posted in late June, which is the biggest problem with lab-grown meat. The biggest problem, of course, is that it's too expensive to produce on a scalable way. It's at least 1,000 times more expensive. This is the comment that I like the most. Thank you for Darth Tinkles, which is a great username, by the way. I think those who support lab-grown meat will need to be willing to absorb a hefty initial cost to make this viable on a larger scale. Yes, we call this the first or early adopter tax, but getting meat without animal slaughter is a pretty incredible thing. But during the video, you mentioned fetal bovine serum, which is derived by cows. Surely these companies are not undercutting their whole ethical meat angle by using that serum. Are there other cell feeds they can use that are not derived from animals? That's a great point. I totally missed the first time I looked at this headline. Yes, fetal bovine serum or fetal calf serum. You need that serum to allow the cells to attach to the bottom of the flask and to grow and to replicate in a healthy way. Without that serum, when we put the other nutrient media on our cells in the tissue culture lab and don't add something like fetal bovine serum or fetal calf serum, we literally call that starving the cells. And we do that deliberately sometimes to make the cells think that they're about to die, and then we can trick them into doing things that they wouldn't normally want to do. This is not something that cells can live without, and it is derived from animals. Not to say that maybe you couldn't have synthetic fetal bovine serum, so maybe you could make fetal bovine serum synthetically without having to collect it from animals. And also it could just be a byproduct of rather ethical treatment of animals. Maybe you wouldn't have to slaughter lots and lots of animals to get this serum, but nevertheless, this is a huge sticking point, isn't it? We don't actually know what these companies are adding to the cells. It is part of their proprietary mix. Their nutrient slurry can have anything in it, but if anything is in it, has animal products and has animal products that are obtained through harming animals at some stage of the pipeline, this whole endeavor is going to be compromised, not just from a resource perspective, but also from an ethical and marketing perspective. So that's why this comment is pinned. I think it's a great point. Thank you, Darth Tinkles, for leaving this comment. Some of the comments here. The price is definitely the big issue now. This person has also done some cell culture, and it costs a few $100s just for the standard cell culture protocols. Growing cells in 3D would probably cost way more. 3D versus 2D, that's an interesting thing we should talk about. When we grow cells in flasks, most of the time we are just wanting them to propagate in 2D. If you imagine the flask has a certain amount of surface area in the plastic, we just want to cover the bottom of the flask. If they start growing on top of each other, that is where it gets into more 3D territory, and the cells will need even more growth factors and even more nutrients to allow them to grow on top of each other without killing each other, because every layer of cells needs access to nutrients. Whereas on the flask, you can just float the nutrients on top of the cells and they will live just fine. Again, any comment that you can leave me to help me understand what is more in line with what you want to hear or how you found my work, that will all be very helpful. And on that note, it is time to conclude this episode of the Crossover Connections with Jack Wang podcast. You can find our work on Apple Podcasts, Spotify, Google Podcasts, as well as on YouTube. The YouTube channel is Biolab Collective with Jack Wang. As always, thank you for listening. I'm Jack. Hope to connect with you again next time around.